Hi everyone, in this video we're going to look at network management. So in network management, there are a few protocols that are dedicated for this purpose, and we are going to look at these protocols. The first protocol that we're going to look at is the Cisco Device Discovery. So device discovery dalam Cisco digunakan proprietary protocol Cisco Discovery Protocol or CDP. So dia berfungsi di layer 2. Jadi dia akan tengok semua devices yang share the same data link layer protocol. So semua device yang berfungsi dekat layer 2 can run this CDP protocol. For example, kita punya router, switch dan juga access server. So cara dia berfungsi adalah dengan menghantar CDP messages ataupun advertisements kepada semua directly connected interface. So kita boleh tengoklah semua neighbor yang connected dengan that particular device. So dalam advertisement ni dia akan hantar information mengenai nama device, jenis interface dan berapa interface yang device tu ada. So by default, CDP is enabled on all Cisco devices. So kita boleh verify kita punya settings for CDP by using the show CDP command. So for example here I have in packet tracer, show CDP. So it's saying that it is sending CDP packets every 60 seconds. So this is the advertisements sent out all the interfaces that have devices connected to it. And it has a hold time value of 180 seconds. And the advertisements is for CDP version 2. So now by default, the CDP is enabled on all interface. So here we have two physical interfaces that has been enabled. Let's say we want to disable per interface. So we can disable on the interface that we want. For example, we enter interface 0/1. And we can disable the sending out of advertisements out through this interface gig 0/1 by entering the command no CDP enabled. So by right, the CDP is still enabled on the router, but there is no advertisement going out from interface gig 01. Next, we can use the show CDP neighbors to look at who our neighbors are. So for example, show CDP neighbors here. So we have as a neighbor, router 1 connected to the local interface gigabit Ethernet 0/0. And the platform for router 1 is C2900. So that's the model of the router connected to router 2. Ada lagi satu command, we can use neighbor detail. So kat sini termasuklah dia punya IP address dan the Cisco iOS version. So you can use these commands to complete the lab later on about CDP. Next, kita tengok the open standard version of CDP, which is LLDP. So LLDP is short for Link Layer Discovery Protocol. So it's a vendor neutral neighbor discovery protocol, meaning dia open standard lah. So tak kisahlah kita pakai device daripada vendor mana, kita boleh enablekan this protocol untuk dia discover all the devices connected to it. Macam tadi CDP hanyalah meant for Cisco devices. Konsep dia masih sama, dia berfungsi di layer 2. So dia akan communicate with all the devices connected to its interface dengan menghantar advertisements mengenai diri dia kepada device-device lain. Dan device lain juga samalah konsep dia. They will send advertisements about the important information that they have. So, konsep LLDP lebih kurang sama, begitu juga dengan command dia lah. But by default, LLDP is not enabled on Cisco devices. So, kita boleh enablekan dia dengan menggunakan command LLDP run. So, kalau tak nak, kita no kan dia lah, no LLDP run. So, now it's all already enabled. So, we can do show LLDP neighbor. Okay, so here we have router 1 lah. This is assuming that I have already enabled LLDP sebelum ni lah. Okay, but you need to check on the real devices whether it's already running or not, because usually by default LLDP is not enabled. You only enable CDP by default, so you have to enable it first. So kita boleh juga verify show LLDP macam tadi show CDP. So untuk LLDP, show LLDP. So here we have advertisements are sent every 30 seconds. So berbanding dengan CDP tadi every 60 seconds. The whole time is 120 seconds berbanding dengan CDP, which is 180. Right? So those are some of the few differences between the two protocols. So let me just check the interfaces. So let's say we want to enable the transmit and receive. So kita kena enablekan dia separately. Okay, so command dia adalah go into the interface. For example, the 0/1 path Ethernet. So it's already on. So you have to use LLDP transmit and LLDP receive. Okay, so dia bukan macam CDP where you go inside the interface to enable it per interface, dan kita enablekan terus. So dia ada both transmit and receive. Untuk LLDP, dia ada separate between the transmission and the receipt of LLDP advertisements. So another show command that is similar to CDP is show LLDP neighbor detail. Okay, so konsep ni masih sama lah. So dia ada the port number, the software platform, and here dia ada the physical media capabilities, which means kita ada senarai all the interfaces yang ada dekat the neighbor. Next, let's look at NTP. Network Time Protocol is one protocol that is important in terms of network management, sebab bila kita sebagai network administrator, kita selalunya akan log whatever events that happens dalam kita punya network. Jadi kalaulah the time dekat setiap device adalah berbeza, jadi kita susah untuk troubleshoot sebab kita tak boleh tentukan urutan events yang berlaku because the time reference adalah different. Jadi kita boleh gunakan network time protocol untuk synchronizekan the clock on all our network devices. So kalau secara traditional without using NTP, we just set the clock dengan gunakan command clock set. So itu just imagine when we have multiple devices, beratus-ratus for example, it's impossible for us to manually set clock settings on each of the devices. So it's better for network management to use NTP. So dengan NTP, kita ada satu reference server. So the NTP server sebagai master, dan semua device yang lain, bila kita configure NTP, dia akan refer kepada the NTP server untuk dia punya clock settings. NTP server ni can be a private master clock ataupun kita set satu server dalam network kita yang menjadi reference to master clock dia. Ataupun kita boleh set network kita refer kepada NTP server di luar that's available on the internet. So in this case, bila dia keluar tu, cara dia hantar information ataupun message adalah using the UDP port 123. So kita tengok dalam NTP, when we have a reference, kita referkan the keboleh percayaan kita punya server ini dengan menggunakan stratum. So kita ada hierarki lah, yang paling boleh percaya maksudnya kita punya master clock, stratum dia kosong. So any devices yang directly connected dengan server or the stratum 0 server, the stratum 0 device, kita kira dia sebagai stratum 1. So hierarki dia bertambahlah selagi sejauh mana that particular device is from the original time source. Okay, so original time source is stratum 0 dan dia bertambah, okay, based on dia punya distance kepada stratum 0 device. So dia punya hop count ini adalah 15. Okay, so kalau stratum 16 maksudnya device is unsynchronized lah, dia tak boleh reach the stratum 0 device. So in terms of configuration, you can first look at the current device clock settings by using the command show clock detail. So if it's not referring to any NTP server, maybe it's going to state the clock is hardware calendar or is based on user configuration. So if it's hardware, it's based on the clock in the router or switches processor. If it's user configuration, it means that you have somehow set the clock by using the set clock command. So you enable reference to an NTP server by using the command NTP server and the IP address of the server. So you can verify the reference now using the show clock detail again. So it should state that your time source is NTP. So kita boleh verify juga dengan gunakan show NTP associations. So kita boleh check lah the stratum level of our reference clock dan juga kita punya stratum level. So in this case, router 1, dia punya stratum level adalah 2. So kita refer kepada time server at 200.22. Next, let's look at SNMP.
SNMP, or Simple Network Management Protocol, has become the standard for network management because it's a simple and easy to implement protocol, and it's supported by nearly all the vendors. So this protocol defines how management information is exchanged between 1, SNMP manager, and 2, the SNMP agents. So first kita tengok SNMP agents dahululah. Okay, so this is like a client software that is installed on the devices yang kita nak jaga, yang kita nak manage. So we want to know valuable information mengenai kita punya device. For example, kita punya memory consumption, kita punya CPU power dan sebagainya. Kita nak tahu status dia up ke down. So we install the SNMP agents on these managed devices so that we can collect device information and translate it into a compatible SNMP format. So kita mesti ada satu language yang difahami oleh kita punya SNMP manager supaya dia faham. We know that kalau kita sebagai humans, we can understand the languages about memory power, CPU dan sebagainya. So now kita nak letak ni sebagai valuable data yang boleh difahami oleh devices of the machine, so dia boleh do some alert ke, so kita boleh buat some management task lah. Okay, so we call this as a management information base. So basically they are collections of definitions of the managed objects. So management information base ni dia simpan segala macam definition mengenai keadaan sesuatu device. So macam saya cakap tadi, so, contohnya we can have the CPU power, we have the memory usage, we can have whether the printer is on or off, we can have whether there are any errors going on the router. So kita nak tengok supaya kita boleh diagnose the condition of our network. Okay, so the SNMP agents keep the database of values for definitions written in the MIB. So dia bagi MIB ada senarai apakah term-term mengenai sesuatu device, dan MIB ni akan dipenuhi oleh value untuk setiap device by the agent. So what the manager does adalah dia perlu poll. Poll ni macam periodically tanya, send some message, are you okay, or please give me the condition of your device right now. Okay, so the SNMP manager periodically polls the SNMP agents on the managed devices by querying the device for data. So dia bertanya, apa keadaan kamu sekarang. Okay. However, kalau on normal condition, kita boleh poll lah kalau tak ada berlaku sesuatu. However, periodic polling has a disadvantage. A delay occurs between an actual event occurrence and the time the SNMP manager pulls the data. Maksudnya, kalau lah kita kata, okay, kita hantar poll setiap 5 saat. Mungkin pada saat yang kelima, dia poll that this machine is doing okay, but sebelum sempat sampai ke saat kelima yang kedua, something happens to this device. For example, there is a link down on a router. So how does the manager know? So sebenarnya SNMP ada define lagi satu cara lah. Maksudnya kita kena event triggered by the agent itself. If something is wrong on this managed device, the agent needs to send a message to the manager instead of waiting for the manager to send a poll. Okay, so ini jenis-jenis SNMP messages lah. So we call it SNMP process. So in normal conditions, we can have the manager send a poll by sending a get request message. Okay, and then the managed device or the agent will send a get response. So dia akan jawab mengikut a specific MIB variable lah. So once they dapat response for the first MIB variable, will get issue the get next request. So kita since setiap managed device ada beberapa variable, so dia akan issue all the polls according to the MIB variable lah. Okay. Also, the manager is able to send a set request. Set maksudnya instead of just getting the value, the manager can set specific value. So, ini mudah untuk network administrator buat configurations lah. Okay, so send a set request to all the managed devices. Then you can change a certain value in the MIB variable. Okay, yang saya cakap, katalah sebelum sempat sampai the get request daripada the manager for polling, if there is something that's happening to the managed device, then the SNMP agent can send something called a trap. So this is an unsolicited alarm condition. That means if there is something happening to this MIB variable that is below the threshold ataupun not normal, then it will send something like an alert or an unsolicited alarm kepada manager, so that the manager gathers this information and knows what to do. So that's the whole simple process about SNMP. It's basically just asking, are you okay? And if the managed device is not okay, then it say, hey, hello, pay attention to me, I'm not okay. So that's why we say it's a very simple network management process, sebab the logic behind it is very simple. Let's look at the SNMP versions. So first we have version 1. Okay, so in version 1, we have the SNMP messages that you've seen just before. Get request, get next request, set request, get response, and trap. However, this version is rarely used nowadays, mostly because of security purposes lah. Okay, then we have version 2 where they introduce get bulk request, so that we can have a polling yang more efficient lah, boleh dapatkan beberapa jenis variable dalam satu masa, or we can poll large amounts of data. And they also have another type of message called an inform request. So instead of something called a trap, they call this an inform request. Okay, so they added the expected acknowledgement. Maksudnya once you alert the SNMP manager, the manager needs to send an acknowledgement so that kita tahu bahawa manager tu sudah terima the alert. Okay, so version 2 also added 64-bit counters to accommodate faster network interfaces. Okay, because network technology pun berkembang. Okay, and then version 2C is like an extension to version 2 because they have some sort of a username and password combination yang dipanggil community string. Okay, however, community string ni by default it is not encrypted. Okay, so bila community string basically bila kita nak poll, the manager and agent needs to have the same combination of community string, so the manager can get valuable information from the agent from the correct group lah. Maksudnya orang-orang tertentu sahaja yang boleh poll. The correct or the identified manager can poll for information from the devices only the verified manager and the verified agent. They need to have the same community string. Cuma it's not that secure because it was not encrypted. Okay, now the latest version is version 3. So dalam ni kita kena ada instead of community string, there is a username and password authentication and also encryption. Okay, so that's why it sets methods to ensure the secure transmission of critical data between the manager and agent. So we know that now SNMP, even the SNMP messages might be used by malicious parties to attack kepada kita punya network devices. Okay, so SNMP v3, as I've said, dia dah tambah security measures. So dia tambah beberapa levels of security. So one, this is called no authentication and no privacy lah. So maksudnya there is no setting when you set no authentication and no privacy, you do not want lah. That means you trust your network and there is no authentication required and no encryption provided. Okay, the next level is authentication and no privacy. In this case, we only need authentication, and the authentication is based on a hash message authentication code, MD5 or secure hash. Okay, but in this case, there is no encryption. We just require the authentication. The highest level of security for SNMP v3 is both authentication and privacy lah. So in this case, dia punya encryption is using cipher block chaining. So some SNMP best practices or guidelines. Okay, so restrict access to read only. This means the manager only reads the values or get the values, not set the values. Okay, supaya kita tak nak there is some breach of security and allows a person yang menyamar menjadi manager to change the parameters of our devices. Okay, so not through SNMP. If we want to change the parameters of the devices, maybe through a scripted configuration lah. Okay, so tak nak melalui SNMP. Okay, and if we want to use SNMP to set values, you can use the right access with separate credentials. Okay, so for normal purposes, use a combination of username, password yang different and username and password yang different untuk kalau nak set values. Okay, and this is to be used under very careful consideration. Okay, and then set up SNMP views to restrict manager to only access needed sets of MIBs. Not all MIBs are available to all sets of manager credentials. Then how you want to restrict lagi, kita boleh gunakan ACL. Okay, and then of course use the latest SNMP with the authentication and encryption features where possible. Okay, so kena of course if there are kalau ada budget company, that means you can upgrade your devices that support SNMP v3 lah. So Z and the group that the name belongs to. Okay, group Z. And then we want to enable traps, which means this switch should be able to send a trap should anything happens to this tree view status. So it should send to a server, and the server IP address is this one. Okay, so we want to send a trap in version 3 tetapi hantar trap hanya untuk value CPU and port security punya messages. So hantar alert if something happens to the CPU or the port security. Okay, And this one is just for, let's say the switch is shut down and then it's restarted or rebooted, the interface index for this switch will remain. So as a reference, this is the SNMP command that we have seen before. Okay, so that's it for SNMP.